This is a very important question. So once you make a mistake in this question, you are going to lose so many marks in CUT-PG, because there will be so many questions from the most repeated question is about the Nernst equation in CUT-PG. Now, coming to the question, the reduction potential of hydrogen half cell will be negative. You are asked to calculate the reduction potential at which the E cell is equal to a negative value. So, what are the conditions? The concentrations are given here. So, if you write the Nernst equation, for writing the Nernst equation, what will be the equation for the reaction of this one? It is called as hydrogen half cell. So this reaction will be like 2H plus, if I'm writing the reduction reaction with the 2 electron, will be giving you H2 gas. H2 gas. So this is our reaction, and you can see that N value is equal to 2. So if I write the Nernst equation for this one, E is equal to, here the standard Nernst equation, E0, which is the EMF at the standard condition, minus 0.0591 by N log of the products divided by the reactants. So what is the product here? Product is hydrogen. So you can take the pressure of partial pressure of hydrogen divided by concentration of H plus. There is 2H plus, so you have to take H plus to the power of square. And of course, you know the 0.0591 by N, that comes from the constants, which is RT by F, the normal value. Now, let us see the conditions one by one. So, we are asked to determine when will be the E value will be negative. For this value, so here E0 is equal to 0. Why? Because this is a hydrogen electrode, standard hydrogen electrode. Its E0 will be equal to 0. So, if you rewrite that equation, it will be E equals minus 0.0591 by 2 log of partial pressure of hydrogen divided by H plus square. So for this value, total value to be negative, already there is a negative sign here. So it will be determined by the value of this term, log of pH2 by H plus square. So now we have to determine those values, which meaning to say log of pH2 by H plus square. Whenever this value is positive times negative, you will be getting a E value of negative. So you have to check when this will become positive. So to check that, you can directly see options one by one. So first option. What is first option? P of H2 is equal to 1 bar and H plus is equal to 1 molar. So it will be log of pH2 by H plus square, which will be equal to log of pH2 is 1 divided by H plus square, and that is 1 molar. So that will be 1 square. So that will be log 1. Log of this value will be equal to 0, meaning to say your E value will be equal to 0. Now let us check the second option. What will be the second option? So again log of, I am simplifying it, log of 1 divided by pH2 is 1 bar, H plus is 2 molar, so that will be square. So square of 2. So 1 by 2 square. So this will be equal to log of 1 by 4, which is 0.25. Now 0.25, of course, this value will be negative. If this is negative, E0 will be equal to positive. So this value you are going to get a negative value, since log is less than 1. Now let us check the third option, that will be log of, Here it is 2 bar divided by 1. So log of 2 by 1 will be equal to log of 2. Log 2 is greater than 1. So this value will be greater than 1. So the meaning to say if this e value will be equal to negative. Now in the last option, again this is log of 2 divided by 2 square. So this will be equal to the 2 by 2, so 1 by 2, so that will be log of 0.5. Log of 0.5, again this will be equal to e value, the total e value will be equal to positive, since this is a negative value. This will be negative here, log 2, this will be a positive value. So the right option you can see, it is the option number 3. So this is your right option. Always in this type of Nernst equation, you have to remember the Nernst equation, which is E is equal to E0, and also RT by NF. Here there is a correction, there will be 2.303 into RT by NF. If you are taking the log value, then only you will get the 0.0591. Thank you.